Hi there, it's Miss Heaton, signing in to talk to you today about chemical reactions. First of all, I want to talk a little bit about the terminology we're using here. A chemical reaction is what's actually happening in the real world, where one chemical turns into something else. It's the actual real world stuff that's happening. We're going to use this word, or this phrase, chemical equation, to represent the symbols that we'd write down on paper that would be a shortcut way of talking about what actually happened in that reaction. Let me give you an analogy. Let's say you want to make brownies. Actually making the brownies, mixing the stuff together and putting them in the oven and producing the brownies, that would be the reaction. The equation would be the recipe. So you'd say that you mix the brownie mix from the box with some water and some eggs and some oil. You put them in the oven, and then at the end you'd have the brownie. So the equation is the recipe that you follow. We also are going to be using some symbols that you should be familiar with, and I'm just going to run through these real quick before we get into some real chemical equations. The first symbol here you've already seen before. This just means it reacts and turns into. So you could pronounce it as yields or produces. So the things on the left are what you have before, the things on the right are what you have after. So reactants on the left, products on the right, and the arrow says the reactants produce the products. If you see an arrow like this, it's got, ends going both ways. That means that the reaction can go both ways. So we talk about that as being at equilibrium, and we'll deal with that in a later unit in more detail. If you see something like NaCl, the chemical, with an S in parentheses after it, that means that you have solid sodium chloride. If you saw NaCl with an L after it, that means that you have liquid sodium chloride. And if you saw something that had a G at the end, you got it, it would be a gas. Now this other one, AQ, is a little bit different. What that means is that the substance has been dissolved in water. And so you could talk about NaCl liquid, that would be pure liquid NaCl, or you could say NaCl AQ, aqueous, and that means that the sodium chloride was mixed with or dissolved in liquid water. And finally, we have a symbol where we have the arrow, the yields arrow, with a chemical above it. That means that the chemical above the arrow is a catalyst that speeds up the reaction. So you may see any or all of these symbols as we deal with chemical reactions and chemical equations in the coming days. There's a couple other things we should talk about in terms of symbols. Let's take this reaction as an example. We've got two hydrogen peroxides producing or yielding, breaking down into two water molecules and one oxygen molecule. Hydrogen peroxide is the stuff your mom may have put in your cuts if you skin your knees and it bubbles and it burns and it cleans out all the infection there. And this is the reaction that it undergoes when it does that. So let's first talk about these numbers in front of the chemical symbols. Those are called coefficients. They show the ratio of the molecules in the reaction. So two hydrogen peroxides turn into two waters and one oxygen. Those coefficients are what we'll use to balance equations later this week. And then the numbers at the bottom, inside the chemical formulas, are called subscripts. These cannot be changed as we balance equations, and they're there to tell you how many atoms of each element are in the molecule. So in hydrogen peroxide, you always have two hydrogens and two oxygens. In water, you have two hydrogens and one oxygen. And in oxygen, it's diatomic, so it's got two oxygens in it. So coefficients versus subscripts. And now, one more thing we're going to talk about are the ways that we could classify or divide reactions based on their type. And this is going to be useful as we start thinking about, well, how can we predict what will be made in a reaction? And one way is to tell based on what you're starting with and what you're ending with. So I'm going to give you an analogy here. Let's say you're at the homecoming dance and you see a cute guy or gal across the room, you lock eyes, you started out single and you ended up together in a compound dancing, you're dating. So this is a combination or synthesis reaction where two or more elements are what you start with. You start with simple things, and at the end you form a compound, so now they're together. Our example here is sodium reacting with chlorine to make sodium chloride. By the way, you'll get a handout of this later with these pictures, so you don't need to draw the pictures in your notes, unless you want to. Okay, now this is a little bit sad. Decomposition is the second kind of reaction, and it's the opposite of a combination or synthesis. That's where things are going great, you're dancing together as a compound, but then you mutually agree that it'd be better to be single. And so you break up into the elements that you came from. So in a decomposition reaction, you start with a compound, and it breaks down either into elements or into simpler compounds. So an example of this is hydrogen carbonate breaking down into water and carbon dioxide. So it's broken into two different things. Third kind of reaction is a single replacement reaction. This is where you start with an element, so a single person, and a compound. And this guy says, hey, I kind of like this girl. And yes, it's a girl. She's got a skirt on. Girls can have short hair too. And then this guy gets kicked out of the picture. So you have an element and a compound. This guy replaces this guy and he ends up alone. So at the end we have the yellow shirt guy with the green shirt girl, and the purple shirt guy is by himself. In our chemical equation, that would be represented with zinc, the element, replacing the hydrogen in hydrogen chloride and kicking out the hydrogen. So at the end you have the zinc with the chlorine, and then the hydrogen is by itself. And we'll talk later about why there's subscripts of 2's here. It has to do with charges. Double replacement reactions. This is like a double date switcheroo. So you start with two compounds, two couples, and the girls say, hey, I like your guy better. And then the other girl says, hey, I like your guy better. And so they switch places. And so at the end, the blue shirt girl is now with the yellow shirt guy, and the green shirt girl is now with the purple shirt guy. And so in our chemical reaction, we see that we've got sodium chloride and silver fluoride. When those two compounds react, they do a switcheroo. So the fluorine switches places with the chlorine. So at the end, you have the sodium and fluorine together, and the silver and chlorine together. So anytime you start with two compounds, this tends to be what occurs. And last but not least, we have combustion. This is where you get really upset with your ex and light their hair on fire. Well, not really. But it does involve burning. There's not really a good dating analogy for this. Please don't light anyone's hair on fire. In a combustion reaction, you're always going to start with a carbon and hydrogen compound. It could have lots more carbons or lots more hydrogens. This is a simple one. But you'll always start with just carbon and hydrogen. It will react with oxygen, like oxygen in the air, that's why stuff burns. So this O2 will always be the same. And they always make the same products, carbon dioxide and water vapor. So carbon dioxide and water are always produced when something combusts or burns. So if you see carbon and hydrogen and oxygen as your only reactants, you know that it's a combustion reaction and will always make these two products. Okay, here's what I'd like you to do. On your notes, write down A, B, C, D, E, and classify each of these types of reactions as one of the 5 types that we just talked about. So hit pause, try that, and then tune back in here in a minute. Okay, here are the answers to the 5 practice problems. Check your answers. If you did not get one right, please look back at your note and see if you can figure out why. If not, please ask your teacher in class tomorrow. Okay, Miss Heaton, signing out.